All right, so before we continue with some of these number line examples to help us figure out where a graph is above the x-axis or below the x-axis, are there any homework questions you guys want to go over? I know we've only really finished one section, but it's an important section of factoring, so let's go over anything you need to go over. Yeah. 10. Which page is that? 21? Oh, that's a good one. Okay. All right. So page 121, number 10 at the bottom. It says factor each of the following polynomials, then identify the zeros, aka x-intercepts. Show your work. Did you try to factor that one? Did you notice anything you could do? Okay. And was that it, or could you keep going? Was that it, or did you keep going? That's the farthest you can go. Okay, so we're going to try to figure out if this was equal to 0, what would the solution or solutions for x be? So in your factoring here, we only have one section or one factor that has an x in it. So this is the one that we're going to focus on to help us solve for x. So we're essentially trying to figure out when does this factor equal 0, or what value for x would make it be 0. So how would you solve that equation? Good, Brianna?
Add 4 to the other side and then the cube root of it.
Okay, so we know to get rid of a power of 2, you have to square root. So to get rid of a power of 3, you'd have to cube root. I know the answer looks a little strange, okay, but the x-intercept of this graph would be the cube root of 4, whatever decimal value that might be. Is that good, Hannah? Okay. Are there any other ones you guys want to go over? Yeah.
Can you do number 2?
Number 2 at the top?
Mm-hmm.
Okay. All right, so at first glance, when I look at that, I notice how the terms are kind of jumbled. You see how it's an x to the 3rd first and then an x to the 5th. So what I would do is put it in standard form, put all the powers in order. All right, and then think about factoring. So is there a GCF we can take out? Do you notice anything that all of those share? Either a number or variable? Yeah.
I took out negative 3x.
Okay, a negative 3x. So we'd be left with a positive x to the 4th, a negative 2x squared, and a negative 8. Okay. Are we done, or can we keep going? Keep going. All right, so the factor that's left inside those parentheses kind of fits the I am profile. It has an a value of 1. So let's try to think about two numbers that multiply to negative 8 but add to negative 2. Yeah. Negative 4, positive 2. Okay. And since this factor had an x to the 4th in it, it's quartic. We're going to put 2 x's in each factor. Okay, evenly break up those 4 x's. So again, ask yourself, can we keep going or are we done? Yeah. Yep, we can keep going on that first factor there. We have a difference of squares. Yes?
Should we have an x after the 4 and after the 2? Because it's x squared.
Not necessarily, because if you were to go through the FOIL process, this x squared times 2 would give you a 2x squared, and then this negative 4 times the x squared would give you a negative 4x squared, and when you combine those you get that middle term.
So
it's only based off of that first term, okay? Yep. Alright, so difference of squares, we can have x plus 2, x minus 2, and then the x squared plus 2 can't go any further. that okay, Griffin? Okay. Any other ones? No? Alrighty. Let's go ahead and take a look at page 125. We're going to take a look at an example today without the graph, okay? I know the graph is kind of provided at the bottom of the page, so try not to look at it, but we're going to see if we can solve this inequality, okay? When is this polynomial specifically less than or equal to 0? Meaning, when is its graph, well, you guys tell me, less than or equal to 0, what does that mean? What are we trying to identify on the graph? Yeah. All right, so the less than or equal to means on or below the x-axis. Alrighty, so what we're going to do is try to figure out the x-intercepts first. Okay, where are we on the x-axis? And we can use those values on our number line to kind of make up our little intervals. And then we'll go ahead and test some points to see what else is happening within those intervals. Are they positive or negative, meaning above or below the x-axis? And the ones we specifically looked at yesterday, we know to figure out x-intercepts we have to factor first, okay, and then set it equal to 0. Do you notice, hopefully, how this polynomial they give us is already factored? Do you see how you have those little groups already provided? So factoring might not be necessary in this case. If you were to set each of those factors equal to 0, what would your x-intercepts be? Can you give them, Marie? Yeah. There we go. All right, so a lonely x is always 0. To cancel out a positive 2, you need a negative 2. And to cancel out a negative 2, you need a positive 2. So we have 3 x-intercepts. Okay, we can label that this is we are on the x-axis at those spots. So we're going to utilize those locations on our number line. So if we know we're on the x-axis at those locations, we got to figure out, are we above or below the x-axis in between those values? Kind of what's happening graphically in between the x-intercepts. So pick any number you want between negative infinity and negative 2. Good, Marie? Negative 4. Okay, so let's go ahead and plug in negative 4 into the factors. We would have a negative 4, which would make it a positive factor. Then we would have negative 4 plus 2, which would result in a negative factor. What about negative 4 minus 2, and then you square that value? You would end up with negative 6 squared. Negative 6 times negative 6? Yeah. Positive, okay. So what's a positive times a negative times a positive? Yeah, negative. Perfect. Okay, so we're going to continue through our little number line, picking any number you want that's appropriate and making sure you plug it in. We're just concerned about the signs, positive or negative. The number value doesn't really mean anything. Between negative 2 and 0, probably negative 1. So if we go ahead and plug it in, we'd have initially negative, and then the second one would be positive, and the third one would be positive. All multiplied together. Wait, the first one would be positive if we're plugging in a negative 1, so that would change it to a positive. For our next interval, something between 0 and 2, probably 1. If we plug it in, the first factor is negative, second factor is positive, third factor is positive, so overall negative. And then something between 2 and infinity, whatever you want. So the first factor, negative, second factor, positive, third factor, positive, multiplied together would give us negative. All right, so we initially decided, okay, off of the inequality that was given to us, that symbol less than or equal to 0 means we need to be on or below the x-axis. So based off of our little sign chart or number line there, can we determine those intervals? Where are we on or below? Can we label them? Okay, so we're looking for negative locations, okay, negative values, meaning below the x-axis. So it looks like we have this interval, and then we have these two intervals on the end. So we can go from negative infinity to negative 2. Can we include negative 2? Yes, okay, that's a spot where we are on the x-axis. That was an x-intercept, and we said we could include those values, so we can use a bracket. And then our next interval looks like we go from 0 and then to 2, but we could count 2, right, because that's on the x-axis. So we'll keep going through our interval, and it looks like we'll go off towards infinity. So we can bracket 0 and then go off towards infinity. Okay, no graph provided. Okay, or at least maybe hopefully you didn't reference the one at the bottom of the page. But we can still analyze above the x-axis, below the x-axis, just based off the equation. Okay, not necessarily needing the graph. Let's say you wanted to check your work though. Okay, if you were able to have the graph like the one at the bottom, let's go ahead and check to see that these intervals we developed were correct. So we initially said that we're looking for where the graph would be below the x-axis. So we could highlight or maybe bold in those regions. So based off the graph, it looks like we would have the same interval from negative infinity to negative 2, where we're on the x-axis, so we can bracket that. And then from 0 to infinity, we're on the x-axis at 0 and 2, but we can include those values. Okay. It says explain how your sign analysis, okay, that little number line, positive or negative values at the top, is confirmed by the graph. So we'll say these intervals are where the graph is on or below the x-axis. Okay, so visually, based off the graph, we can confirm that the results we had from our little table were correct. What if I decided to switch it up a bit? Okay, if you take a look at the question at the bottom, what if we had the same polynomial, but I switched the inequality to greater than or equal to 0. Okay, how would our analysis be a little different? What are we looking for in this case? Yeah?
It would be the section that was positive or union that's
Between the two negatives. Okay, so if we want to be positive, we want our graph to be above the x-axis. And then since we have the bar there, that means we could also be on the x-axis at those spots. So that inequality specifically means we are on or above the x-axis. So can we identify the interval or intervals where that happens? Either based off of the little number line we did at the top, or maybe you can reference the graph that was given to us. Notice how the positive region, on the number line at least, is between -2 and 0. And it looks like that's checking out on the graph too. Okay, we're above the x-axis from -2 to 0. And if we want to include those x-intercepts, okay, where we are on the graph, we can bracket -2 and bracket 0. So it's basically the other region of the graph that you haven't really answered from the other example. Okay, Okay, so if this was asking where we're below, this one would be asking where we're above, because we're switching that inequality. Are we doing okay? We didn't lose it from yesterday? I like these number lines. I think they're a little fun. Okay. Yeah?
What about where it touches to on there?
Explain. Oh, good catch. Okay, so we have this interval, and how would you show just that point touching to? How would you want to label that? So we have this entire section, and then just that spot.
Just right here.
And, okay, so we'll say the x value of 2. Good catch. All right, let's go ahead and try another one. We'll flip to the back. Okay. All right, so this time we're going to consider the polynomial at the top. What's a little different about this one than the other ones we've been looking at? At first glance, do you notice anything that's a little strange? Yeah.
It has a number other than 0 on the other side.
Right. Notice how this one is greater than or equal to 3. Okay, all the other ones were somehow compared to 0, right? And 0 is kind of that special location on a graph because 0 is what separates positive numbers from negative numbers. So what we want to make sure is happening, at least in these inequalities, is that we are comparing it to 0. So how can we get a 0 on that other side instead of the 3 there? Good, Maddie? Let's go ahead and subtract it over. Okay, so maybe as a little side note, we want the inequality to be compared to 0. Did I spell compared right? Yeah, it just looks weird for some reason right now. Okay, so now that we have it compared to 0, let's see if we can continue through this number line process. Okay, we first want to figure out where we are on the x-axis, okay, those zeros. So you got to think about, can we factor that polynomial? Is there anything you want to try? Yeah?
A times C adds it to B.
It looks like that, right? Okay?
It has to be squared.
It has to be squared, exactly. So that power of 3 is kind of throwing everything off, okay? Because normally it's a quadratic, meaning a power of 2, or a quartic, power of 4. We've seen some of those. But that power of 3 is throwing us off. So unfortunately, this one cannot be factored. So how on earth can we still figure out where is this graph above or below the x-axis? Okay, so for instances like this, where you cannot figure out by hand using the factoring to figure out the x-intercepts, we're going to go ahead and utilize a graphing calculator. Okay, so that's why I need you to get one today. So we got to make sure initially that we're being compared to 0, okay, because we are looking for where are we above or below the x-axis. We're then going to use the calculator to help us graph it. So we're not necessarily going to use a number line in this case because I know you guys are really good. Once you have a graph, I think you can determine where you're above and where you're below. So this is kind of a shortcut by using this guy. So let's go ahead and try to graph this polynomial. I know it's been a while. Do we remember how to graph an equation? What buttons we press? Where do we go? Yeah. Y equals. Okay, if there's anything in there, go ahead and clear it out. And we're going to type in the polynomial x to the third minus 9x minus 3. Now before you hit graph, let's go ahead and change our window. If you look at the table that's provided for us, we definitely know how far left and how far right we should be looking. So those would be the x min and max. We can go from -5 to +5, counting by ones. But they don't label the y-axis for us. So this is where we can just pick any values we want. What's the lowest y value and highest y value you guys want to use? We can always go back and change it. Yeah. You want to do tens? Okay. And then count by ones. I think that'll be okay. All right, so the equation's in, window is set. Let's go ahead and hit graph. All right, that's pretty good. We can't really see the dip down there, but at least we can assume that there is kind of a low point or a minimum there. So draw a rough sketch, it says. Okay, draw what you see to the right. So initially, what we should be looking at are those x-intercepts to try to guide us. It looks like we have an x-intercept really close to -3, but not quite. We have another one that kind of looks like -0.5. And then another one that's a little bit more than 3. Okay. So we know those points are pretty important, yeah. It's saying error. Let's check it out. All right, so with those x-intercepts provided, we need another calculator one? Error 2. All right, so we're going to play connect the dots with these x-intercepts, but at least having the general shape of the graph. So we go up, curve back down, and then come back up again. Okay, so there's a general graph based off the calculator that we used. Okay, so what we're trying to do here, okay, based off the inequality, is look for where we above or below or on the x-axis. Can we say specifically which one of those options we're looking for based off the inequality? Greater than or equal to 0 means what? What should we be focusing on? What should we be looking for? Go, Rebecca. On or above x-axis. Okay, so with the graph provided, we can probably highlight those regions. Okay, we're looking for this little section there and that one here. Okay, but we need to know what those x-intercepts are. Okay, what are those crossing points exactly? So we're going to let the calculator kind of do the work for us. So what we're going to do in this middle box right here, they call it the 0 function. It's an option on your calculator that you can use to help you find the 0, aka x-intercept of a graph. So on your calculator, we're going to go to Second Calc. Hopefully that menu looks a little bit familiar. We use that at the beginning of the year to help us do maxes and mins. Does that sound familiar or look familiar? Notice how the 0 function or command is number 2. So we're going to go ahead and select that one. So the moment you select that 0 option, you have that little spider or cursor dude pop up, and it's asking you a question. Do you see how it says left bound? Okay. So what we're going to do is we're going to move that little cursor to where you think maybe the first x-intercept is located. It might not land on it exactly, but just try to get it close. So what we're going to do is hit the left arrow a few times. We're going to pick a point to the left of where we think it is. And a little arrow is going to pop up somewhere on your screen. You might see it. We're going to move the spider back to where you think it is. But now notice how the question changed to right bound. So you're going to hit the right arrow a few times, doesn't really matter, and hit enter. there should be another arrow that pops up on your screen. So what you're telling the calculator is the x-intercept you want to find is between these two spots, okay, between those two arrows. Because notice how there are other x-intercepts, but you're just trying to figure out this one right now. So the last question at once is a guess. You're going to go back to where you think it is and just hit enter. So after picking that left point, that right point, and then your guess, the calculator should give you that x-intercept exactly. So let's go ahead and write that first one down. Looks like -2.817. Maybe we'll do 3 decimal places. Yes? Came up with an error. Let's check it out. Do you guys think you can give the other 2 x-intercepts a try? Okay, go back to that menu, okay, second calc, and it's option number 2. So if you guys reference your notes at some point, it might not be a bad idea to write down the buttons or kind of the process you might need to use for this 0 command or option. So we got to hit the second button and then the trace button. You're going to choose option number 2, that 0 command. You got to pick a left point, then a right point, then your guess. Can we get those numbers? Calculator doing okay? Alright, so now that we know these spots exactly, let's go back and try to answer the question at hand. Where is this graph above or below the x-axis? What do you guys want to write? Can we write our intervals? Good, Rebecca, yeah.
I got in brackets.
Yep.
Both of these are brackets.
Okay.
I got -2.82 because I only did 2.
You did 2, that's fine. Okay.
Yeah, and then I got to -0.34.
Okay.
And then union,
Mhm.
and then another bracket, 3.15 to infinity with the parentheses.
Perfect. Okay. So based off of those exact spots that we know, we can go from the first x-intercept to the second x-intercept, including them, because we have that bar. And then the last interval, we only have one x-intercept to include but notice how it's going to go off towards infinity because we have that arrow. Okay. How'd you guys do? Pretty good? Perfect. Okay, so in terms of your homework, I just want to take a look at it for a second. I know you guys can do the top chart on page 127. Okay, the graph is provided, and you can use that graph to help you answer those above or below questions. But the rest of the homework at the bottom of the front page and on the back are the ones without the graphs. So you're going to have to utilize that number line to help you out. But again, the tricky thing is, if you can't factor, you're going to have to somehow get a graph, okay, like we did today on the calculator. So if you have your own calculator, that's nice, but I know some of you don't. So just as a reminder, if you need to graph something, go to that Desmos site, desmos.com/calculator. And you can type in the equation you want, and it'll automatically give you a picture. You can also figure out x-intercepts on that website too. Okay? You can always borrow a calculator when you're in here too. If we have extra time, you can utilize those. Okay? So we still have about 10 minutes left. I would suggest maybe trying some of these just for extra practice. Okay?